The question asked for in this video was specifically about Part C. If you have questions about the other parts, look in the playlist for Chapter 4 and you will see another video labeled similarly that goes through Parts A and B in more detail. So I'm just going to focus on Part C since that, again, was what was asked for. And we're making a composite function here, f of x, which is the same thing as f of x, written like this. And I'm going to kind of try to color code a little bit here if I can. So first of all, we have this function f of x, which is equal to x over x minus 7. So where I see f of x in the inner function, I'm going to replace that with x over x minus 7, and then wrap that inside the f function, just like this. Now, you might think, well, that's the same function, but it's okay. We can replace this into the x values of the f function. So it's going to look a little complex, and that's okay, but just note where those x values are, those inputs are here and here. So I'm going to write out the larger function. It's an input value over the input value minus 7, like this. And what this new input value is x over x minus 7. So where you see these big circles, I'm going to replace that with x over x minus 7 in both places. So this is a complex fraction and probably not the way that you want to keep your final answer. So after that, this is going to take some algebra to simplify. Okay, so I'm going to move this up a little bit so we can focus on simplifying this larger expression here for f of x. I'm going to start with the denominator, and to subtract two numbers like this where one is a fraction, I need a common denominator, and that's going to be x minus 7. So I can say here I'm going to take this second term and multiply it by x minus 7 over x minus 7. That doesn't change anything with that term, but it provides me a common denominator. So at least at this point, what I can write, I'm going to put it over here for some space, in that denominator, we'll write x over x minus 7 minus 7 times x minus 7 over x minus 7. That's the way that's going to look. I'm just going to repeat the numerator just to keep everything together here, like so. I am distributing a negative 7 into this set of parentheses here, so just keep that in mind as we work that out. So that now becomes plus a negative 7x plus 49 over x minus 7. Now that these two denominators are the same, I can combine their numerators by adding them together, and we get negative 6x plus 49 over x minus 7 in the denominator, and I'm just going to bring over that same numerator as before. Okay, so I need to move up some more for some more space. Now this is really just a big division problem. So when we divide fractions, we take that numerator and multiply by the reciprocal of what we're dividing by. So the reciprocal of this looks like so, where I've just flipped the numerator and denominator. And you'll notice something really nice happens. The x minus 7s will cancel out, and we're left with the following equation here, or expression rather, for f of x. And at this point, there's nothing else I can do to simplify, and so that's why this would be the expression used. To answer the question about what is the domain of this composite function, I need to come back up, and I need to find any domain restrictions within the inner function. Here's the inner function. And inside this function, x cannot equal 7, because if it did, I'd be dividing by 0. That's a problem. So when I write the domain, x cannot be 7. And then I need to find any domain restrictions of the composite function. So again, the denominator here cannot equal 0. So I really need to come off here to the side and work that problem. When will the denominator be 0? And that happens when x is 49/6. So that's another place that I want to remove from the domain. So altogether, I can say that the domain is x such that x is not equal to 7 and x is not equal to 49/6, and this is the final domain of the composite function.